Assalamualaikum. Hi guys. So today we continue topic 5 bivariate analysis. So what is the learning objective of the topic? So at the end of the lesson, you will be able to identify the independent and dependent variables. You can determine the relationship or correlation occurred between independent and dependent variables using scatter diagram and Pearson's product moment correlation coefficient method. Third one, you can find the regression equation or regression model using least square method. And last one, from the regression equation, you can estimate or you can predict or you can forecast the response variable given the predictor value. Let's look at the introduction. So the researchers are interested in finding out the relationship between the variables. So they will use correlation coefficient value to determine the significant relationship between the independent variable and dependent variable. For example, a doctor might be interested in the relationship between the quantity of cigarettes a patient smokes per day and the level of nicotine in their blood. So which one independent? Which one dependent variable? So from this example, the quantity of cigarettes a patient smokes per day is independent variable or factor. Meanwhile, the level of nicotine in their blood is a dependent variable or commonly known as response variable. So, the doctor can identify the relationship occurred between the two variables using the correlation coefficient value. Then, after that, the researchers also interested to predict the value of response variable, to predict, to forecast, to estimate the value of response variable in case the factor is already known. So the aim of the regression equation is to find the best fit equation to represent the two variables. So when the researchers interested of two variables means that one is linear regression equation. Why? Because one independent variable and only one response variable, two variables. So that one is linear regression model. What is correlation? So correlation measures the relationship between the two variables. What is the two variables? First one is independent variable known as predictor or factor. So this variable influence the dependent variable. Dependent variable known as response variable measure the effect of the independent variable. Means that dependent variable depends on independent variable. The method to identify the correlation. So first one is scatter plot. Second one is Pearson's product moment correlation coefficient. First, let's look at the scatter plot to identify the relationship between the two variables. So scatter plot used to describe the relationship or correlation between the two variables. So this one, perfect negative correlation. So perfect negative correlation X increase, Y decrease. So this one becomes a negative correlation. But look at the points. Lie on a straight line. Therefore, first diagram represents perfect negative correlation. Meanwhile, second diagram, perfect positive correlation. X increase, Y increase. All the points lie in a straight line. Next, negative linear correlation. So third diagram compared to first diagram, this one. Look at the point. Okay. So third diagram represents a negative linear correlation, not perfect. Number 4, positive linear correlation. So this one compared to second diagram, perfect positive correlation, but this one represents positive linear correlation. And then this one, no correlation or no relationship occurred between independent and dependent variable. No pattern. And then this one, curvilinear correlation. Here, X increase, but Y may be increase or decrease. So this one, the difference pattern of scatter plot to identify the relationship between the two variables. Next, Pearson's product moment correlation coefficient. So compared to scatter plot or scatter diagram, we just plot the point to identify the relationship between the two variables. But this one, we can measure the strength of the relationship between the two variables. So the Pearson product moment correlation coefficient denoted by R. And the value of R is in between -1 to 1.0. So what is the formula? These two formulas. You can use either one at the end, same answer. So you must know and represent the number of observation. What is the summation of xy, summation of x, summation of x squared, summation of y, and last one, summation of y squared. Meanwhile, this one, when you got the value of R, you can interpret or explain or comment the value of R. So let's say here, in between 0.8 to 1, positive sign, therefore positive linear relationship between x and y. So look at the value. If the value between the range, therefore strong positive linear relationship between x and y. Let's say when you calculate R equal to 0.6871. So command the value obtained. So look at the value here between 0.5 to 0.8. Positive sign, so positive linear relationship between x and y. So what is the strength? Moderate. Positive linear relationship between x and y. So this one, how you want to calculate the value of R, and also how you want to combine to interpret or to explain the value of R obtained. Let's look at first example. Determine the relationship between the amount of fertilizer used and the yield of mango fruit in GGG plantation using Pearson's product moment correlation coefficient and explain its meaning. So from this data, you need to identify which one independent variable and which one is dependent variable. So look at the sentence here. The first variable, which is the amount of fertilizer used, so that one represents X. Therefore, number of fruits becomes Y. X independent variable, Y dependent variable. So to calculate or to identify the relationship between the two variables, you will use this formula to calculate R. So obtain all the values, then substitute at the end. The correlation coefficient equal to 0.8271. What doesn't it mean? There is strong positive linear relationship between the amount of fertilizer used and the number of fruit produced. Or you can use this statement. There is strong or there exists strong positive linear relationship between the amount of fertilizer used and the yield of mango fruit in GGG plantation. So this one, how to calculate the Pearson's product moment correlation coefficient value and also how to interpret the value obtained. Next, we proceed to coefficient of determination. So previous example, you have learned how to calculate Pearson's product moment correlation coefficient, which is denoted by R. So this one, coefficient of determination represents the ratio of the explained variation to the total variation. So this one, explained variation to the total variation. So coefficient of determination denoted by R squared. So R squared will explain how much of the variability in dependent variable that can be explained by the independent variable. So the keyword here is the variability in dependent variable can be explained by the independent variable. So the closer the coefficient of determination to 100 means that the more important of independent variable in predicting the dependent variable. So this one, the formula on how you want to calculate the coefficient of determination value. So this one based on correlation coefficient R. So R squared times 100. So for example, given the correlation coefficient value of the relationship between the amount of fertilizer used and the yield of mango in GGG plantation is 0.8271, find the coefficient of determination and explain its meaning. Means that you need to calculate R squared based on this information, 0.8271. Therefore, R squared equal to 0.8271 squared times 100 equal to 68.41%. So how to explain? Recall back this explanation of R squared. Therefore, 68.41% total variation in the yield of mango fruit in the plantation can be explained by the amount of fertilizer used, while the other 31.59% can be explained by other factors. So this one, 31.51% means that 100 minus 68.41 equal to 31.59%. From correlation coefficient, we proceed to simple linear regression. So the word simple linear regression, linear means that the power of x or the power of independent variable equal to 1. So regression is a statistical technique used for investigating relationship between the independent variable and dependent variable using least square method. So first, you need to find the regression coefficients A and B. So A, constant value. Meanwhile, B, slope or gradient. Second, you can generate the linear regression equation or linear regression model. Y equal to A plus BX. So Y, dependent variable, A, constant value, B, slope value, and X represents independent variable. Okay, so this one, the formula on how to find the A value and B value. So we will use this formula to calculate A and to calculate B. So the assumptions of the regression model. First one, the variables are independent. Second, normal distribution. And last one, equal variance. So this one, based on scatter. So look at here. Y, dependent variable. X, independent variable. So first line here, the regression line or the regression model to represent the line. So here, B value, positive value, means that X increase, Y increase. Second, maybe you will got Y equal to A minus BX. So minus here means that X increase but Y decrease. Okay, so next look at here. That one and then this one. So this one represent A. A. So A, when X equal to 0, Y equal to A. Same as here, X equal to 0, Y equal to A. So this one, how to find the linear regression model using the least square method. Let's try to do this example on how to find the linear regression equation or linear regression model. A researcher wants to study on how age affects car insurance rate among customers of insurance GH. Find the linear regression equation for the following data using the least square method. So, based on the data, identify X and Y. So, first value or first variable is age, X. Second variable, insurance rate, Y. Which one comes first? That one is X. So, using the data, find all the values n equal to 10, summation of x 418, summation of y 236, summation of x squared 19400, summation of y squared 5836, and summation of xy 10557. So first, find the b value using the formula. Substitute all the values at the end. The value of b equal to 0.3591. Next, find a constant value. Substitute all the values. So this one, b values 0.3591. At the end, a equal to 8.5896. Then, recall the regression equation. Y equal to a plus bx. Substitute the value of a and then the value of b. So at the end, y equal to 8.5896 plus 0.3591x. So this one, the example to show on how to find the linear regression equation, or how to find or how to develop the linear regression model. Y equal to a plus bx. So now, regression coefficients. Recall back. What is the regression equation? So regression equation based on two regression coefficients, a and b. So a here is a constant or known as y-intercept. So a, the estimated value of dependent variable when the independent variable is 0. Next, b. So b known as slope or gradient. To interpret the value of b, you must remember this statement. One unit change in the independent variable, therefore the dependent variable will change by b units. So look at here, increase or decrease. Let's say you got the b value is a positive value. So this one, increase. If negative value, decrease. So, to interpret the value of b, you must look at the sign of the b value, either positive or negative value. For example, b equal to 0.3591. So what doesn't it mean? For 1 year increase in age of customer, the insurance rate will increase by 0.3591. So look at here, increase. Why? B is a positive value. Then substitute the value of B. Next example. So this one, B, negative value, negative 1.233. So explain its meaning. For 1 year increase in age of used car, the selling price will decrease by 1.233. Negative value, therefore decrease. Third example, explain the value of A. the constant value A equal to 12.2814. When there is no fertilizer used in fruit plantation, the number of fruits produced will be 12 units. So recall back this one. When x equal to 0, y will be A. Next, we continue with task for adequacy of linear model. So this one, we want to test either the regression model is significant or not. So we will use this mini tab output based on F value or P value. So assume that both the variables are normally distributed, thus at 5% level of significance whether the regression model is significant or not. So let's say first approach, we want to use the p-value approach. First step, set up the H0 and H1. So H0, the regression model is not significant. Meanwhile, H1, the regression model is significant. Second step, state the p-value. So p-value here equal to 0.000 and alpha 0.05 based on 5% convert to decimal form. So recall back the concept of p-value approach. We will reject H0 if and only if the p-value is less than alpha value. So reject H0. Why? Because the p-value is less than 0.05. Therefore, at 5% level of significance, there is sufficient evidence to indicate that the regression model is significant. Okay, next, second approach. Let's say you have no p-value. So, you can use F-value approach. So, first step, set up the hypothesis, H0 and H1. The regression model is not significant. The regression model is significant. Then, state the F value. So, F value here equal to 297.84. Next step, find the critical value from the F table. F value, F table. So, we will, based on this degree of freedom, regression, and then the error. So, when alpha equal to 0.05, V1 equal to 1, and V2 equal to 7, the critical value equal to 5.59. Therefore, reject H0 because the F value greater than critical value. So as a conclusion, at 5% level of significance, there is sufficient evidence to indicate that the regression model is significant. So you can test for adequacy of linear model based on p-value approach or f-value approach. Okay, so this one using same data, calories and sodium, we will focus on model summary and also the coefficients. So for model summary, look at here, R squared. So R squared coefficient of determination. So from the data, R squared equal to 97.71%. Say you want to calculate coefficient of determination's value equal to 97.71%. So first, from the data, calculate R. Next, from the value of R, you can calculate R squared. So R squared equal to the correlation coefficient value squared times 100. From the R squared value, you want to know what is the correlation coefficient value. So from R squared, R equal to square root R squared. 97.71% convert to decimal form. So R equal to 0.9771. You must know how to identify independent and dependent variable. So from the statement here, which one comes first? Number of calories. Therefore, number of calories is independent variable. Meanwhile, sodium content is a dependent variable. Or you can look at the question that you want to estimate. So what you want to estimate here is amount of sodium. So amount of sodium becomes Y. Okay. So next here, you want to focus the coefficients. So coefficients here, there are two terms. So first one is constant. Constant known as y-intercept. So this one is A. Meanwhile, the independent variable here, calories, denoted the B value. So from this output, the constant value equal to 177.9. Meanwhile, the slope value equal to 0.8188. Positive slope. Okay. Next, assume that both the variables are normally distributed. Answer the following questions. So first question, show that constant value is 177.9. Show that, prove that. So at the end, the final answer must be equal to 177.9. So if you want to show or prove, first recall what is the formula of A. Next, what you need here is summation of Y and B summation of X. So N equal to 9, summation of X 2644, summation of Y 3766, and B value 0.8188 here. Next, substitute all the values into the formula. So at the end, A equal to 177.9, exactly same as question. Okay, so next question, state the regression equation and interpret the value of slope. So this one, the word state. So state, you can obtain the regression equation from the output. So look at the coefficient here. Coefficient A and B. So what is the general form of the regression equation? y equal to a plus bx. So substitute a, substitute b. Therefore, regression equation y equal to 177.9 plus 0.8188x. So this one plus, based on this output, plus signs or positive value of slope. Let's say negative 0.8188. Therefore, the regression model becomes y equal to 177.9 minus 0.8188x. So the symbol here is minus. Okay, next question is interpret the value of slope. So recall back the concept of value of slope. X always increase, but y may be increase or decrease, depends on the sign of slope. So from this example, when the number of calories increase by 1 unit, the sodium content will increase by 0.8188 milligram. Why increase? The symbol here is positive sign. Therefore, increase. Question C. Based on the regression equation, estimate the amount of sodium if the number of calories is 389. So, given x, you can estimate the value of y. Substitute x equal to 389 here. Like that. Therefore, the estimated value equal to 496.4132 milligram. Estimate, predict, forecast of y. Question D. Is it possible to estimate the amount of sodium using the equation in B if the number of calories is 435? So is it possible or not? Based on the actual data, what is the minimum value of independent variable? Minimum value 170. Meanwhile, maximum value 420. So look at here, 435 exceeds maximum value of the number of calories from the actual data. Therefore, no, it is not possible because the value of 435 is out of range of the given data. You can estimate, you can predict, or you can forecast if the value of x within the range of the actual data. Okay guys, that's all about the bivariate analysis. Assalamualaikum.